now let's jump into section 2.2. And in the previous section, we talked about qualitative data. In this section, we're talking about quantitative data. And so this is data that is represented by numbers. It has a numerical orientation, where qualitative data was like the color of the car or the weather pattern that you're seeing, sunny or cloudy. Quantitative data is numerical in its orientation. So something like the temperature is quantitative data. 32 degrees is a numerical type of data, or your height is another type of quantitative data. So when we deal with quantitative data, we can still create bar charts from this, but we can create specialized bar charts with purpose. And these specialized bar charts are called histograms. And histograms have certain properties because they're based on numbers. Number one, they're numerical in order, right? And so as you're collecting data, you're collecting numbers rather than vocabulary words, okay? And these numbers usually have a lower value and an upper value. So we call the lower value the minimum, and we call the upper value the maximum, okay? And if you subtract these two, you can figure out the range of data values that you have. We'll talk about that in just a little bit. The other thing is, because they're numerical, they are sequential. So when you create the bar graph with this, like we mentioned earlier, when I was doing the Ford and the Chevy and the Honda bar graphs, I could arrange these bars in any order that I wanted, right? Like I could move them around if I wanted to. But when we're talking about numerical data, let's say from 10 to 20, from 20 to 30, I can't arrange these bars in any order that I want because they're numerical. And so the minimum values are to the left and the maximum values follow to the right, okay? And they're sequential because they're numbers, right? And we order them from least to greatest, okay? The third and final thing about histograms is that there are no gaps in your x-axis. So as you create your x-axis, if we're talking about maybe temperatures, so you measure the daily temperatures, maybe it starts at 32 degrees and it goes up to 38 degrees. There are no gaps in the sequence. So 32 is there, 33 would be there, 34 would be there. You're not going to make a jump from 34 to 37, right? They're usually equally spaced and sequential with no gaps, okay? And so let's talk about taking quantitative data and organizing it into a histogram. How do you do this? And so a couple of things we'll talk about right off the bat is the range. And the range is pretty easy to find. You just take the maximum value and you subtract the minimum value, right? So if we were given an exam, for example, and let's say that the max score on the exam was a 98 and the minimum score on the exam was a 72, then the range for this exam would be 26. So the range is 26, okay? Then what we want to decide is how many classes do we want to organize this data into? So the term classes is synonymous with the word bins or buckets or containers. It's how many divisions do we want of this data? So if you were looking at exam data, for example, we may want, in this particular case, this exam data to be sliced into, let's say, 4 buckets, okay? So you would maybe go from 60 to 70, that would be one bucket, 70 to 80, that would be another bucket, 80 to 90, that would be another bucket, and then 90 to 100. So it'd be bucket number 1, 2, 3, and 4. So these would be 4 buckets, 4 bins, 4 classes. And so that's another thing that we have to decide is how many buckets do we want? Finally, when you look at our data here, the 72 and the 98, if we take a look at that range, once we know the number of classes that we want, in order to find the width of each bucket, we would take the range, in this case 26, and we divide it by the number of classes that we'd like. So for example, if you wanted 4 equally spaced buckets starting at 72 and ending at 98. If we wanted to take these grades and break them into 4 distinct buckets, you would take 26 and you would divide it by 4. And you're going to get, when you divide 26 by 4, I think we get 6.5. So that means the first fence post is at 72. The second fence post, you will add 6.5 to that 72, and we'll get 78.5. Then the next fence post will be 6.5 from the 78.5. So that's going to be what, 85, I think. And then the next fence post will be 6.5 from that. So 6.5, 6.5, 6.5, 6.5. And that's how you create equally wide buckets with the same width, 4 of them for this particular range. That's how you would do this manually by calculating, okay? And so these are 3 concepts: range, classes, and class width. The class width is the width of each bucket, the width of each class. And you can find that out by taking the range and dividing it by the number of classes, okay? The next part that we're going to show you is something that you're not going to have to do. Google Sheets will build this for you, but it's something that we need to talk about if you were to build these out by hand. And so usually when you're talking about classes, there's a class limit and a class boundary. And we're just going to go over this fairly quickly. And this is probably a better visual. So notice you've got class number 1 right here and class number 2 right here. So this is like bucket number 1 and bucket number 2. And here are your fence posts. So the lower boundary is the lower fence post for class number 1. And here is the upper boundary, which is the fence post for class number 1. So class number 1 has a boundary that goes between these 2 fence posts. Class number 2 has a boundary that begins at the upper boundary of class number 1 and goes over here to the upper boundary of class number 2. Okay, so it's like building fences, right? Now, where things get a little bit complicated is where you talk about this idea of a limit, of an upper limit and of a lower limit. And that are these guys right here. So here's a lower limit and an upper limit. And here's the concept. The concept is, even though we have these fence posts, you need to have a 1 unit buffer between the fence posts. So even though you have a fence post, and that's called the boundary, you have something called a limit, which is 0.5 above the fence post and 0.5 below the fence post, okay? And this limit helps you do a calculation called the midpoint. So when you find the midpoint, you take the lower limit and the upper limit, you add them together, divide by 2, and that will give you the midpoint of bucket number 2 and the midpoint of bucket number 1. And so these are just some terminologies. Again, Google Sheets is going to build this for you, but we have to show you how you would do this by hand if you were to do it by hand. The reason we organize the buckets this way is so that way we can then take our data and sort it into these buckets. And so the final step that you do in this whole process is you find the class frequency. You say class number 1, how many data points fall into that bucket? Class number 2, how many data points fall into that bucket? And again, this is not something you'll have to do manually. Google Sheets will do this automatically for you. But if you were to do it manually, here's an example. We collected 24 student data points, and we asked these students, how much do you pay in rent every month? And this is the data set. So there are 24 items in this data set. The maximum value is $2,550. The minimum value was $350. Again, this is how much do you pay for rent. And so to find the range, we subtract the max and the min, and we find the range of $2,200. If we want to break this up into 7 classes, 7 buckets, 7 columns, then we would take the range, 2,200, we divide it by 7, and we'd figure out that each bucket has a width of about $315. We're going to round that up. It's 314.286, but we'll just round it up to the 315. So that means we're going to start our graph at 350, and we're going to add 315 to it. So that's 665. That'll be bucket number 1. And then we're going to add 315 to that. And so that'll be 980, and that'll be bucket number 2. Then we'll add 315 to that, and that'll be bucket number 3. And we'll continue to do this, and that will establish our fence posts. That'll establish our 7 buckets. Then we're going to go up here and we're going to count the data and say how many items fall into bucket number 1. How many items from our data set fall into bucket number 1? I've got 350, I've got 610, I've got 600, and I think that's it. So there are going to be 3 items in bucket number 1. So we would make a bar that is 3 units tall. And then we would sort them into bucket number 2. And this would take a long time to manually do. So once you get done doing this, this is what your table is going to kind of look like. So here's your bucket number 1, 2, 3, or we would call it the class number 1, class number 2, class number 3. And here's the number. Oh, I think I missed one. Did I miss one up here? There was one more that fell into the, oh yeah, no, not the 690. Right here, 495. I missed the 495. Yep. So there's 4 items from the tally mark, the frequency of 4. So the number of items that fall into bucket number 1 are 4. So that's going to have a column that's 4 tall. Number 2 is 8 tall, 5, 6, 0, 0, and 1. And now that we've got the frequency information, we can make a bar graph that'll look something like this. And notice the x-axis is numerical, right? Each bucket has a width of 315, 315, 315. There are 1, 2, 3, 4, 5, 6, 7 buckets. Buckets number 5 and 6 are empty. Bins 5 and 6 are empty. Class 5 and 6 is empty. And then these have frequencies of 4, 8, 5, 6, and 1. Okay, so this is a great way to organize numerical data. Okay, so let's show you how to do this using Google Sheets. And so I'm going to jump into the 2.2 Google Sheet exercise, and there are instructions for this. So the first thing you want to do is name your range Bob, or call your named range something. So that way it's easier when we enter formulas. The other thing you want to do is find the max, min, and range of Bob. And then we're going to create a histogram. And this histogram has specific instructions. Set your minimum value on your axis to 60, set your maximum value to 100, and set your bin width to 3.3333. We'll show you why in a little bit, okay? So if you click on this, here is the data set, okay? So when you click on this, this is what your Google Sheet will look like. And so the first thing I'm going to do is I'm going to give this data set a name. So I'm going to scroll all the way down. I'm going to highlight all 84 items. I'm going to go to Data, Named Ranges, and I'm going to call this range Bob. So there's Bob. Say hi to Bob, everybody. And now we want to find the maximum value of Bob. So we're going to say equals max of Bob. Oop, there you go. So the maximum score in my data set is 92.3. Now let's find the minimum score. So we're going to say equals min of Bob. And there's the minimum score of Bob. So far, so good. Now let's find the range. So to find the range, we're going to subtract these 2 values. So we're going to use a formula, but we're not going to actually type anything. When you hit the equal sign, it means something mathy is going to happen. And so I can just click on the max value and then hit the subtract key and then click on the minimum value. Or if you wanted to type in the actual cell address, C2 minus C3, you can do that as well. When I hit enter, there is the range. And you may notice that my test score data is random. So if I click on an empty cell and hit the delete key on my keyboard, my test scores re-randomize. Okay. And notice that my max changes in accordance with the new data. My minimum changes in accordance with the new data. And the range also changes because it's based on these two numbers. So we're building a dynamic system, a system that can change when the inputs change, okay? And that's a common theme that we're going to have going on throughout this course, okay? So now I've got my max, I've got my min, I've got my range. That's fantastic. Let's create a histogram. So one thing about the data for a histogram is it has to be in a single column. So you got to have all your data arranged in a single column. So we're going to highlight this whole column all the way down to cell number 85. There it is. We're going to say insert a chart. Now we don't want a bar chart. We don't want a circle chart. We want a histogram. So when I click on chart, Google's going to try to guess what type of chart I want. And it correctly guessed histogram. You can see over here under the chart editor, remember there's two tabs, setup and customize. Setup, customize, setup, customize. So under the setup tab, make sure that it selects histogram. If it doesn't for some reason, then you need to click the drop-down menu and you can go down and find not a column chart, not a pie chart, not a scatter chart. That's the next section. Right here is the histogram chart. So you just click histogram. And here is our histogram that Google guessed. This is probably what it thinks we're looking for. Now you'll notice this histogram, it sorts the data, but look at the x-axis. You see the x-axis, how these numbers aren't exactly what we're looking for? Like we want widths of 3.333, and it's not exactly 3.333. It's auto guessing the width of our bars. And also notice our maximum is not set to 100. And so we need to go in and tweak this graph just a little bit. So again, we're going to double click on the graph, and that'll bring up our chart editor off to the side. We're done with the setup tab. So now let's go to the customize tab. So the first thing we want to do with this graph is we want to set the max and mins 60 and 100. And those lie on the horizontal axis. So we got to scroll down to the fifth item, not chart style, not histogram, not chart axis, not series, not legend, but horizontal axis. Actually, it's the sixth menu down. So when you click on horizontal axis, you can go into this histogram and you can set the minimum value. We'll set that at 60. And you can set the maximum value at 100. And notice how my graph automatically changes. You could set the minimum to 30, and it would put the minimum value at 30. And see how it resorts the data? We're not going to set it at 30. We're going to set it at 60. Okay, so great. Now we got our minimum. We got our maximum. That's it for horizontal axis. Now, what we want to do is edit our bin width. We want to make sure that our bin width is 3.333. Because when you do grades, when you look at grades, and let me explain it a little bit better this way. Going under histogram, where it says bucket size, this is your bin width. This is how wide you want each bar to be. So if we set this at 10, this will sort our data into bin widths of 10, 60 to 70, 70 to 80, 80 to 90, 90 to 100. And it automatically did it for us. That's all we had to do is click on this bucket size. Let's change it to 5. So if we want a bucket size of 5, now it goes 60 to 65, 65 to 70, 75, 80, 85, 90, 95, 100. Okay. Now, when you're talking about grades, if we set it to 10, the first column would be our Ds, those grades in the D range. 70 to 80 would be the C's, 80 to 90 would be the B's, and 90 and above would be the A's, right? But we don't just have B's, we have B minuses and B pluses. And it basically takes that 10, the range of 10 items, and it divides it up into thirds, right? That's why we're going to use 3.333. So even though that's not listed here as one of the options, we can just type it in. So if we go here and we type 3.3333 and hit enter, it will slice our bins into widths of 3.333. So here are the D minuses. The first column is D minus, then the Ds, then the D pluses, then the C minuses, the Cs, the C pluses, the Bs, the B minuses, the B pluses, the A minuses, and then the As, if there are any. Now, some students have asked, if you look at the far right axes, you'll see that there are two 100s there, okay? And some students have asked, why is 100 on there twice? The 100 to the far right, the rightmost 100, is actually the 100 that we put in as our upper boundary when we set our axes. That's that 100. The 100 that's in between the 96.767 and the 100, that number is actually 99.9999, which the computer system rounded up to 100. So if we change our bucket size, and just to emphasize that, if I change my bucket size to 3.33, you see that there's a little bit, it's not quite 70, right? It's 69.99. It's 79.98. And so we need to put that extra digit of 3 in there in order to round this correctly. And when you do that, it adds a 100 there, which really is 99.999, right? So that's why there's the extra 100. Okay, so those are the things we needed to do. Number one, set your max and min for your range on your histogram, right? 60 to 100. So we set those two. Then we go in and we set our bucket size, and this time we did it purposefully with 3.333. And now everything else you want to do is what we did earlier. So you're going to go to chart style. We're going to give it a nice background color. Let's give it this. We'll go to chart and axes, histogram of test scores. So we're going to take that. We'll put it in the center. We'll make it bold. Maybe we'll make it black color font. Or if you wanted to, you could do green, I guess. You can go to series, and we could change the fill color of our bars. We could make that green too. Okay. Legend, we don't really need. Horizontal axis, vertical axis, grid lines and ticks. So if you wanted to put additional ticks in here, like minor grid lines, minor ticks, and we could do the color of these grid lines as black, something like this. So there's all sorts of color variations that you can do to accentuate different parts of the graph if you wanted to. And so this is a graph of our histogram. And once again, it's tied to our data. So if we click on an empty cell and hit the delete key, our data is re-randomized data, and it automatically gets sorted into the appropriate buckets. And so it's nice that Google Sheets does this. If we go back to what we were talking about here, this is the process you would have to do if you did this by hand. You would have to first establish your class limits. You'd calculate that by hand. Then you'd tally up all of your data. And this is just for 24 data points. All of this that we just did right here in example 2.21 is just for 24 data points. Imagine doing all of this for 84 data points. It would take you a half hour to do this whole entire process, where with Google Sheets, it can just do it automatically. So again, 24 data points, we're going to break it into 7 different classes. You identify what the class limits are, and then you go in and you sort your data into those class limits, counting the frequency of each one. And then once you have that frequency, you go out and you create a histogram for it. Okay. So now that we've shown you how to create a histogram, what are some, and here's the relative frequency. So if you wanted to go in and look at the relative frequency of each one, you could graph that as well. So there are certain histogram patterns that you want to be able to identify. And so one histogram pattern is called the symmetric graph. This is sometimes called unimodal, because there is one mode. There is one number that occurs most frequency. And when it's in the center, it's called the symmetric graph. Later on in the course, we are going to call this a normal curve. Well, we're not going to call it that just yet, okay? But later on we will. So this is a symmetrical graph that has a mode in the middle, and then it kind of slopes down to the left and it slopes down to the right, okay? You can also have a bimodal distribution where you have not just one mode, but actually two modes. And so you'll notice that this has a tail that goes to the left, a tail that goes to the right, and then there's this dip in between. We also have distributions that can be skewed, where the mode is skewed one way or another. So this first graph is skewed to the left, the second graph is skewed to the right. The way I remember these is if you were to take this graph and make a ramp out of it and put a ball on that ramp, the ball would roll to the left. So this is a left skewed graph because the ball rolls to the left. On this other one, if you were to make a ramp out of this graph and drop a ball on it, that ball would roll to the right. So that is a right skewed graph. So think of it in terms of like a slide or a ramp. And if you drop something on it, which way would it roll? In this case, it's going to skew to the right. We can also have a graph that is uniform. And so a uniform graph, the ball would not roll at all. It would just sit there. And some students have asked, what's an example of a uniform graph? If you had a six-sided die, and this was the probability of rolling a 1, a 2, a 3, a 4, a 5, or a 6, the probability of rolling a 1 would be 1 out of 6. 1 out of 6. The probability of rolling a 2 would be 1 out of 6. Rolling a 3 would be 1 out of 6. So if you took this dice and you rolled it 6,000 times, so you take the six-sided die, it's a fair die, you roll it 6,000 times, you would expect there to be 1,000 ones and 1,000 twos and 1,000 threes and 1,000 fours and 1,000 fives and 1,000 sixes, right? You would expect an equal distribution of all of the dice rolls. So this would be an example of a uniform graph, okay? And so the last thing that we'll talk about in this section is cumulative frequency. So we have already talked about frequency, right? The number of items that are sorted into each bucket. Now we want to talk about a new concept called cumulative frequency. And cumulative means add them up as you go along to accumulate something, okay? And so in our first bucket, the cumulative frequency is 4, because that's what you're starting with. Then you go to the second bucket and you take the previous value, the previous frequency, and add it to the new frequency. So 8 gets added to the 4 and you get 12. Then we take 5, we add it to 12 and we get 17. We take 6, we add it to 17, we get 23. So this value is the cumulative frequency. It's sort of a measurement of how the data grows, how the frequency grows as we move from bucket to bucket to bucket. And you can graph this cumulative frequency, and it looks something like this. So we started at 4, that was our first bucket, and then the second bucket had 8, which gave us a cumulative frequency of 12. And then the next bucket had 5, which was a cumulative frequency. So again, the 4 is right here. So here's your 4. And then here is the 8 that you added to it. And now we've got the 4 here, we've got the 8, and now we've got the 5. And then on this one, oh man, we've got the 4, we've got the 8, we've got the 5, and then how much is that? An additional 5, right? So another 5 right there. Is that right? Oh, 6, sorry. 23. Yeah, so we had 6 right there. Okay, so this is cumulative. It shows how it grows over time. And this is called an ogive chart. And we're not going to be developing these very much, but it's a good idea to understand cumulative frequency because, again, if you remember your algebra and like y equals mx plus b, the m is the slope of this line. And you can tell how something is growing over time by looking at the slope. So this is how cumulative frequency can be graphed, and it's used as an ogive chart. You can then use this to make predictions. So for example, we may not have an exact data point right here, but we could project up to this and over, like at, let's say 1,200, to predict how many students are paying rent less than $1,200. And that's kind of what we do here. Oh, actually, this should be 1,200 right here. So you can project it up, and then you'd say, well, about 15 students, 15 of the 24 students are spending less than or equal to $1,200 for rent. So you could use this to make predictions about data.